Hello, welcome back everyone. So last time I promised to come back to you with a few Python lines about how to create networks in Python. So this is the day I'm going to show you around in the most basic network library, the most widely used, most popular one, which is called NetworkX. So let's see how it looks like. After zooming myself in as usual, here we are. So here is my nice usual Python terminal. And first, let's just import NetworkX using its usual alias, which is NX. Also, just to make sure we are on the same page, let me see the version I'm currently using in late May in 2014. I have a version 2.5. So that's it for NetworkX, and see what's inside this nice library. So here, if we list its directory, then we can see that there is a bunch of things from which we will use graph, which is the creation of the most simple NetworkX objects, which are undirected graphs. So how do we do that? First, I create a new graph. I will call it G, and we can create it by calling the graph constructor like this. And here you can see that it's a graph class. We can also print the type, so it's truly a graph which has, if you print the number of nodes, so the most basic elements, and we can also print the number of edges, which is the number of connections between these nodes, then they should be 0. So if we add one edge, which we can do by the add edge command, then there should be 2 nodes in the system and 1 edge, right? So there it is. So far, so good. We can add edges, not just integers, but in string types as well. So if I add a new edge like A and B, then we should increase the number of nodes to 4, number of edges to 2, and there we are. And if I do this once again, kind of closing the circle with a link between node 1 and node B, okay, that's fine. Then the number of nodes should remain 4, but the number of edges should be 3, right? So there we are. So that's how simply we can one by one, edge by edge, and node by node build a network. We can also print and list these edges and nodes. So if we type g.nodes, then we will have the nodes in node view, which we can also turn into a list very quickly. And we can also query the edges like that. And if we, for instance, want to iterate over the nodes, we can also do it like this in a for loop, but it's very similar to how we just casted it into a list. So we can just print the node and the type of the node, so we can see that indeed we can have mixed types here, at least at this stage. So that's how we print all the nodes, and we can also similarly print all the edges. For edge in g.edges, print edge, and we can even get the type of the edge, but you can guess what it will be. Sorry, not edges, but edge. It's tuples of mixed types of int, string. So that's what we have seen before. So that's how easily we can create an undirected, unweighted graph. But we can also weight these connections, and we can weight them in a very simple way. I just show you it in a second. So first we need a new fresh start, a new graph. I will call it W because it's going to be weighted. And here I also have some nodes that I will just use as a primer. So first I will say that w.add edge. So I will add an edge here with a weight, better spelling it right, of 1. And then I will just copy it and paste it. So I will link A to C with a weight of whatever, 2. I will link A to D to a weight of 3. That's good enough. A to E, that's going to be 4. And, well, what should we do? Let's connect B to D with a weight of 1. That's good enough for B. And connect B to E as well with a weight of 0.5, because we also can use fractional numbers. And float numbers, this could also be 1.0. Let's link C to E, and I don't know, maybe we can also connect A to E. Yeah, oh no, that's already here. If we would add it here, then we would just probably overwrite it, so just make it to B to E. That's new. Okay, so if we do that, then we will have a nice weighted graph. Similarly, we can query the number of nodes here and number of edges as well. So we have 5 nodes, A, B, C, D, E, and we have 7 edges, which are like 4. Interesting, we have 7 edges, so there is a multiplicity here. Yeah, here you can see B and E, I added them twice, so that's why we have 7 edges. So that's actually nice. Again, we can also print the nodes, which we have seen here before. That's not going to be very surprising. It's already sorted. And the new thing here is that we can query the weight of an edge by calling the get edge data. And let's see the BE edge and see how it was overwritten to 1.0. So you see, if we redefine an edge, then the later value will be added and stored. And we can print the edge weights for every edge, actually. So, for instance, iterating over the edge list and calling source and target, or no, let's call them node 1, node 2. Print, sorry, that doesn't need that. Print node 1, node 2. Equals edge, so we unpack the edge and let's call it weight. The weight should be coming from this comment, so weight equals this, and see, here we got a dictionary, so we get the query, the dictionary's value that belongs to the key of weight. And now if we just print it here, then we should have the weight for every edge here. So, as simple as that, we just created an unweighted network in NetworkX and a weighted network in NetworkX. So, that was it for today. Thank you very much for following, and I will be back later on with other geospatial and also network analytics related projects and videos. So, stay tuned and see you later. Bye.